Hello everyone, my name is Sudhat Kayal. I am third year BTech Engineering Physics student at IIT Roorkee. In this presentation, I will talk about strain gauge strainer kit experiment. The objective of this experiment is to study the performance of the kit and to gain familiarity with its working. Now, strain gauge is a sensor whose electrical resistance varies with change in strain. So we could say that strain gauge is used to measure a strain on an object. Now here we could see a typical foil strain gauge. On expansion or compression of the strain gauge due to the change in area, its electrical resistance changes. Now the strain gauge is connected in a Wheatstone bridge setup along with other resistors. Wheatstone bridge circuit looks like this. Here VEX is the excitation, uh, VEX is excitation source, and we could see here in the strain gauge strainer kit here also an excitation source is provided. So here in this setup, we could see that the strain gauge, this is the strain gauge which is set up on a cantilever beam, and jelly is used for its protection. And this strain gauge is connected in a Wheatstone bridge here with strain gauge excitation source. Now the output generated by this Wheatstone bridge will be passed to a signal conditioning unit, which then will pass from an adder, and through this here in on the indicator it will be displayed. Now as shown in this figure, to perform this experiment we would require a strain gauge strainer kit, cantilever, and weights which are to be loaded on this platform here, and connecting wires. Now before taking the readings, we need to make sure that for no strain or load placed, the reading should be zero. Hence, we have to use a zero adjust for that purpose. Now the task of taking reading is simple. We'll place the load on the platform and then note the readings of resistance. And by toggling the switch, we could uh, read the microstrain produced, and we will note down this reading. Now, as a precaution, we have to place the load in the center of the platform as the readings might get affected due to that. After performing the experiment, I obtained the following set of readings. We can see here that as the weight increases, the microstrain produced is also increasing, and the resistance produced also increases. Now, using the observation in the previous slide, we can now obtain the graph between a microstrain versus weights and resistance versus microstrain. Clearly, both the graphs are quite linear in nature, and due to this, we could calculate the calibration factor, which in this case is 0.00361 ohm per microstrain. Now, due to this nearly linear nature of the graph, we could also say that the strain gauge is performing properly. Thank you for watching this presentation.